here. So if there are no questions, we're going to go ahead and start with notes for today. Okay, I'm assuming that means no questions, so I'm going to leave the PowerPoint. And we are starting our discussion today with absolute value equations. So you may have noticed that there was not a document for you to print or anything today. And that's because we are handwriting notes on notebook paper. So if you'll get out a fresh sheet of notebook paper, we are going to go ahead and start notes. So our notes for today, man, my thing is so unfocused. Okay, so we are taking notes. We're solving absolute value equations. Okay, so we have talked in depth about absolute value equations. We've talked about their transformations. We've talked about them as a function family. You guys have learned how to solve other types of equations. You've solved linear equations, you've solved quadratic equations. And so now we're going to work on solving absolute value equations. Okay, so an absolute value equation looks like the absolute value of x is equal to a, where a is some real number. So a is in the set of real numbers, is what this thing means right here. Okay, so a is just a number, x is a variable, and then our bars represent our absolute value. So when we have an equation like this, it means two different things. We can have two scenarios happen. The absolute value of x can be equal to negative a, or the absolute value of x can be equal to positive a. There's two possibilities. Okay. Now, the absolute value of something, excuse me, hold on, let me fix this. So the absolute value of some number is going to represent the distance from x, whatever that number is, to 0. Okay, so I'm going to imagine, and remember that distance is always positive. Okay. What questions do you guys have so far? I'm going to explain this sentence a little bit more in a second, but what questions do you guys have about the rest of the notes so far? Okay, so I'm going to keep going. So I'm going to explain this sentence by using an example. Okay, so if I have the absolute value of 4, this is just going to be equal to 4. If I chose to have the absolute value of negative 4, this is also 4. This is just saying, oops, this is the worst straight line I have ever drawn. Let me, hold on. Let me fix this. So if I'm drawing a number line, also not a great straight line, but whatever. All right. It's just saying that 4 is 4 units away from 0. So the distance between 0 and 4 is 4. And it's saying that the distance between 0 and negative 4 is the same. So the distance here is also 4. Okay, so that's all absolute value is doing. If I can spell distance, C-E. So absolute value of x represents the distance from x, which is whatever our number is, to 0. Okay, that's why it ends up being always positive, because distance is a value that's always positive. So what questions do you guys have so far?
Can you just give me a second to write all the way down?
Yeah. Okay, so we know that an absolute value equation is, so we can recognize an absolute value equation because it has the absolute values in it. So an absolute value equation will have these midline bars or an absolute value in it. Oops. That's like what defines an absolute value equation, is that it has absolute value bars in it. Okay. So an example of an equation like this would be the absolute value of x plus 3 is equal to 7. Okay, and with this example, I'm going to show you guys how to solve this equation.
Okay, can you slow down, please?
Okay, where are y'all in writing these notes out? Like, what part are you at? So those of you who are still writing, I need to know where you're at. Okay, so I'm just going to slide this up a little bit. Most of it will still be in the screen. All right, so we're going to solve this equation. So that when we have an absolute value equation, we break it up into 2 pieces. Okay, so we're going to have one piece where we have x plus 3 equals positive 7. We're going to have one piece where x plus 3 equals negative 7. So we're taking away our absolute value, okay? And we're doing that, and we're saying that maybe this meant that our distance was positive 7, but it also could have meant that our distance was negative 7. So when we take the absolute value part away, we have to do both possibilities. So we could have the first one or the second one, and we have to solve both, okay? So when we're solving these equations, Brandy, are you there?
I'm here.
So what am I going to do with this first one? How do I get x by itself?
Subtract 3.
Perfect. So I'm going to subtract 3 from both sides. So 7 minus 3 is what, Brandy?
4.
Perfect. So this is one possible answer. Our x value could have been 4, and it would make this absolute value equation true. Okay, now we need to solve the other equation. Eddie, are you there?
Yes.
So how am I going to solve this equation?
You subtract 3.
Good. So I'm going to subtract 3 from both sides. And what do I get?
Negative 10.
Perfect. Thank you. So I have two possible solutions here. I could have that x is negative 10. I also could have that x is 4. If I sub each of these into my absolute value, I can see that it works. 4 plus 3 gives me 7. And negative 7, or I'm sorry, and then negative 10 is here. Negative 10 plus 3 should give me negative 7. But when I look at the distance between negative 7 and 0, that distance is 7. So both of these values will work in my absolute value equation. What questions do you guys have about solving that equation?
So both of those answers are.
Yes, both of the answers are correct. You'll get 2 answers for absolute value equation. Great question. Any other questions? Okay, we're going to go ahead and do it. Oh, was there a question?
Yeah, can we go over one that one won't be the same as the other?
What do you mean one that won't be the same as the other? We have 2 different numbers here.
Like, will we get an equation like it won't be like the same? Like how she just answered both correct. Like,
Oh, I see what you're saying. Like we subtracted 3 in both of these equations to solve it. Is that what you're saying? Yes or no? I couldn't hear.
I said never mind.
Well, I would love to answer your question. I'm just not quite sure I understand. We'll try another example and hopefully this will help out a little bit. So in this next example, I'm going to use the absolute value equation 2 times the absolute value of x minus 8 equals 28. Okay. Now, in order to do this, the very first thing I have to do is get rid of everything. Let me move this little box so that you guys can see. So we're going to get rid of everything outside of the absolute value first, okay? So the thing that's on the outside of the absolute value is this 2, okay? So I'm going to maybe highlight this so that you know what this is referring to. So we need to get rid of this 2. To get rid of this 2, I'm going to divide both sides by 2. And I should get the absolute value of x minus 8 is equal to 14. Okay. I get 2 equations from this. I should get that x minus 8 is equal to positive 14 and x minus 8 is equal to negative 14.
I have a question.
Yeah, what's your question?
Why you put those 2 lines between 2 and the x and behind the 8? Because that's confusing me.
These are the absolute value.
Do we have to necessarily put them?
Yes, absolutely. Because the whole point of this is that we're solving absolute value equations. And they have to have these absolute value bars in order to indicate that we are doing an absolute value equation. Okay, if you need to make them maybe bigger to help you out, that's fine. If maybe you're confused because they're making it look like ones, but those absolute value bars must be in the equation. Okay, now to solve each of these, I need to add 8 to both sides. And I have to do this with both of my equations. My equations are very similar, okay? And so I'm going to add 8 to 14, and this should give me that x is 22. And that's my first solution. And when I add negative 14 and positive 8, I should get that x is -6.